Nucleophilic substitution reaction. In the case of nucleophilic substitution reaction, the nucleophile will come and attack the substrate molecule. Okay. As a result, what will happen? As a result of this, the group displaced from the leaving group will displaced from the carbon atom with the electron pair. Okay. Nucleophile will come and attack the substrate molecule. Okay. Okay. As a result of this, the leaving group will displaced from carbon atom with the electron pair. Okay. Displaced from carbon atom with the electron pair. Let us see how it happens. Let this be the compound. Okay. X is having partial positive charge, partial negative charge. Okay. So, in such a case, what will happen? The nucleophile will come and attack and with X minus. Okay, this will be the reaction. Okay, this nucleophilic substitution reaction are of two types. Which are they? First one is SN1 reaction or unimolecular substitution reaction or SN1 reaction, and the second one is bimolecular. Okay, bimolecular nucleophilic substitution reaction or SN2 reaction. Let us see one by one. First one, SN1 reaction. SN1. This is a first order reaction. Okay, let us see how it happens. It is a two-step process. The first step is the formation of the carbocation. Formation of carbocation. So, in the case of the compound, okay, X, first the cation is formed. Okay. This X will displace from the carbon with the electron pair, and this is the slowest step. Okay. So, since this is the slowest step, it is also the rate determining step. Now, second step is the capture of nucleophile. Okay, by the substrate molecule. Capture of nucleophile by this carbocation. Okay, by the carbocation. Carbocation will attack this nucleophile. Okay, and the product is obtained. This is a fast step. Since the first step is the slowest step, that step is the rate determining step. Okay. In that case, only the substrate molecule is present. So, rate of the reaction is proportional to the concentration of the substrate. It's proportional to concentration of substrate molecule. So, this is also called as the first order reaction. This is the first order reaction or unimolecular reaction. Now, in the case of tertiary compound, we know that the carbocation obtained is highly stable in the case of tertiary. So, SN1 reaction takes place readily in tertiary. So, order of the reactivity will be for SN1. Order of reactivity will be tertiary, then secondary, then primary. Okay. See, let us see one example. CH3, Cl. Okay. Presence of water. Okay, from which the OH minus nucleophile comes from the water. The solvent used is water. So, OH minus will come and attack. Okay. The compound, the product obtained will be OH plus HCl. Okay, this will be the reaction. So, this much about the SN1 reaction. Okay. Now, second type is the SN2 reaction or bimolecular reaction. It is a second order reaction, SN2. Okay, bimolecular reaction, it is a second order reaction. Now, what will happen in the case of this? In this case, both the nucleophilic attack and the product formation and the leaving group will leave from the site is taking place simultaneously. Okay, so both the concentration of the substrate and nucleophile takes part in the reaction. So it is a second order reaction. Okay, now in this case both nucleophilic attack and leaving of the group, leaving group displaced from the site, leaving group displaced from carbon atom takes place simultaneously. Okay, takes place simultaneously. Let us see how it happened. Simultaneously. Now, see. Okay, nucleophile will come and attack, and this nucleophile will come in the opposite direction of the leaving group. Okay, so the compound will be the transition state or the intermediate will be like this transition. Here the nucleophile will come, here the substrate. Next step is the leaving of the displacement of the X. Okay, so the compound will be again nucleophile will be like this. So this is the intermediate step or the transition state. These two takes place simultaneously. So rate of the reaction is proportional to both the concentration of the substrate and the concentration of the nucleophile. Okay, so it is a second order reaction, and in this case we can see that the inversion, in this case the inversion of the configurations takes place the same as the umbrella moving up during the wind. Okay, so this process is also called as the inversion of configuration. Okay, inversion of configuration. Okay, inversion of configuration. It is a second order reaction. Okay, now what will be the stability? We know that this takes place through the transition state, and transition state is a bulkier group, bulkier state. So in the case of tertiary, the compound, the transition state obtained will be highly bulkier. So SN2 reaction is very little in the very feeble. The SN2 reaction will not take place in the not takes place in the case of tertiary. So SN1 will proceed in the case of tertiary, and in the case of SN2 the primary compounds will takes with the reactivity of primary will takes place easier. So the stability of the the reactivity of SN2 reaction will be takes place readily in the case of primary, then secondary, then tertiary. So this will be the reactivity order of SN2 reactivity order in the case of compounds. Okay, primary will takes place more. Now next, in the case of some other compounds like allylic compounds and benzylic compounds, allyl bromide, take one example, allyl bromide. This is allyl bromide. Okay, allyl bromide. So in this case, first carbocation is obtained because the carbocation obtained is resonance stabilized. We know that if the resonance stabilization takes place, the compound will be highly stable. Okay, so this reaction, SN1 reaction, takes place more easier in the case of allylic bromide. The resonance structure will be like this: CH2 plus resonance structures are obtained. Okay, so SN1 reaction, this SN1 reaction takes place in the case of allyl bromide. And what about in the case of benzyl chloride? Benzyl chloride, see, benzyl chloride, CH2Cl. In the same stage of here also the carbocation obtained will be like this. Okay, and we know that the carbocation obtained will be stabilized, resonance stabilized, lots of resonance structures for this compound. See, here first, okay, here plus charge, double bond, CH2. Now here it moves, then the structure will be like this, CH2 plus one more structure is possible. Next structure will be double bond will move here, okay. So different resonance structures are possible. So carbocations are highly stabilized. So SN1 reaction takes place in the case of benzylic compounds also. Okay, this much about the nucleophilic substitution reaction.